Hello, my name is Paul Montalvo, and today I will teach you about new exponent laws when you're trying to switch a number in power form to root form. So first, let's talking about what is an exponent. An exponent is pretty much the number of times a number is multiplied by itself. So for instance, let's say you have 5. I'm just going to put random numbers here. Let's do 3 different numbers, 8 and 21. These big numbers are your base numbers. Well, your base constants. So let's say you have your exponent for the 5 is a 4. This means, as I said, it's a number of times the number is multiplied by itself. Meaning this is going to be 5 times 5 times 5 times 5. Let's say this is 8 with the exponent of 2, which also means to the power of 2. So if you hear me refer to saying something as something's to the power of a number, it means same thing as to the exponent of. So it'd be 8 times 8. And same thing with this 21. Let's say it's 21 to the power of 3. This means 21 times 21. Whoops. Times 21. So now that we have all of the base of what exponents are, we are going to start talking about the main exponent law. Before explaining the whole new exponent law, I'm going to explain some of the number sets I may be referring to. So the first law I'll be talking about is whole numbers. Whole numbers are just numbers without fractions. For instance, this would be 0, 1, 2, 3, 4, 5. So just numbers without fractions is pretty much the easiest way to how to explain it. And the second number set I will be talking about are rational numbers. Rational numbers are a number that can be expressed as a quotient or fraction of two integers. For instance, 1 over 2 is a rational number. 5 over 7 is also a rational number. 6 over 45 is also a rational number. And just know these numbers can be expressed as decimals. For instance, 1 over 2 is also equal to 0.5. 5 over 7 is also equal to 0.71, and this is just rounded. There are many numbers that go after this. And then 6 over 45 is also equal to 0.13. So keep that in mind during the lesson. With this new exponent law I'm going to introduce today, this is only for situations when you are to get a big constant right here, or any constant of any kind, with an exponent that may be a fraction or not a whole number. Whole numbers are numbers that are like 0, 1, 2, 3. So it's like those set of numbers that are like full numbers, no decimals. Because decimals are rational numbers. Let's say 1.5. 2.2. These are rational numbers. So when it comes to rational numbers or numbers that are not whole, how are you going to do this exponent? Because normally if this was to be like 5 to the power of 2, 5 to the power of 2, you just do 5 times 5. But you can't do 5 times a half. Like, that's not possible. But with this new exponent law, it is. When we're talking about exponents, and using this new exponent law, you are looking at the inverse of exponents, which is a root. For instance, if you are going to have 5 to the power of 2, this inverse is square root of 25. As you know, 5 times 5 is equal to 25. The opposite of any kind of exponent is a root. So the root would be a square root, so a root to the factor of 2. So 25 with a square root is 5. So now, talking about this new exponent law I'm going to introduce right now, I'm going to use variables. Variables are just letters that represent any number that you could use for the situation. So for instance, I'm going to use a as the big base number. This a represents any number of any kind you'd want it to be over to the power of m over n. This small m over n represents the constant of which is a fraction. So now, as you know, the inverse of it, like I said, is a root. You're going to get your big base number and put that under the root. All you're doing right now is you're putting the exponent and you're splitting it up. So the denominator is also equal to the factor of which what the root is. So over here. And then this numerator is also equal to the factor, well, by factor I mean the number of which the exponent is to a, so a to m. And this is the main exponent law we are going to be using. Say for instance you have 6v to the power of 1.5. 1.5 is a rational number, but just not put into a fraction. It is put into a decimal. 1.5 is equal to 1 whole and a half. And a half, yep. So in this case, let's just use small denominators such as, let's say 2. So we can safely say 1.5 is equal to 3 halves. So let's rewrite this whole statement. So 6v is also equal to 3 halves. So now let's put it into its correct form, is to the root. And as we know, this is the m value. And this denominator is the n value. This whole 6v counts as the big A base. So we're going to put this whole 6v under the root. Make sure to have this main brackets as the 6v's together. And as you know, the m value goes on to the 6v, and then the 2 goes on to the root. So these two are equivalent to each other. There are many situations wherein you are given the root form of a question and you have to put it back to the exponent form that you were given. For instance, let's say you're given a root of a cube root of x over 15. In this situation, we're just working backwards now. So like I said before, a is equal to m over n is equal to the n root of a m. As you can see in this situation, your big A is the x, like I said before. So this is going to be your big numeric base that we were talking about all the time. And then as you could see, the placeholder of the exponent to the x, well, in this situation to the a, is m. So that's going to be the numerator of the exponent, so 15, right? And then as we know, the placeholder of the n in this question is a 3, so it's going to be 15 over 3. So when you're just working backwards, all you really need to know is just look for the a value, which is your big numeric base, look for the m value, which is your numerator, and then look for your n value, which is the factor to the root. And as you know, this could be simplified to x to the power of 5. Yeah. 2. So another exponent law I'm going to go over, which may apply to the one that I just taught, is that if you are to get a, so any big constant number, to the power of, let's to a negative power, let's say -2, all you have to do is you have to flip the reciprocal and then switch the negative to a positive on the big A value. So you'd flip it and then you just switch this value to the positive. And this goes for the exact same thing. If you are to get an A at the bottom, and then let's say this is a negative. This is a whole different question now. And you want to flip it, this would also be equal to a2. Keeping that in mind, let's go over situations where you may get a rational exponent, which may be negative. So if you are to have your big A was your 3 to the power of 1 over 5, negative on the 1. Whoops, that's a negative on the 1. Whoops. We're going to do what I taught before. You're going to take your big A value, put that under the root. Your n value is your 5. So that's going to be the factor of the root. And then negative 1 stays on the A. In this situation, all you're going to do is, like I said, you're going to get the reciprocal of the A negative 1. And just keep that whole thing under the root. So as you can see, I flipped it. And then the negative 1 is going to be a positive 1 now, and it stays with the A. And the factor of the root stays the same. So all you're really doing right now is you're going to insert your values into the roots and the respective places of m and n. And then if you are to get a m value which is negative, you're just going to get the reciprocal and switch the signs from either negative positive or positive negative. Now we're going to go over situations when you are given something in root form which has a negative exponent and a fraction under the root. So you're pretty much just working backwards now. So let's say if you are to get a root of to the factor of 18 to 1 over 36 to the power of negative 2. Like with the rule I just stated before, which is a to a negative root is equal to the reciprocal of a to the flipped exponent. So what you're going to do is you're going to work from inside out if you were to get this kind of question. So as you know, the root to the factor of 18, you're going to flip this reciprocal, which is 36. And remember, because we're moving it up over here, we're moving this back down, you have to flip the signs to the power of 2. So now what you could do from this point is you already have your a value when you're simplifying. You already have your m value, and this is your n value. So now let's just insert it back into the main exponent lot, which I explained before, m over n. So this would be 36 to the power of 2 over 18. And if you're going to further simplify it, 36 to the power of 1 over 9. Because you could divide each of these out by 2. So pretty much whenever you do get questions like these with a root and a fraction under the root with a negative exponent, you're just working backwards by simplifying it from the inside and getting your a, m, and n values.